IP addressing, in which we are going to see the different classifications, followed by subnetting. Subnetting will take long for us to finish, so you need to be mentally prepared to do some calculations. The only difficult part in this course is subnetting. All the rest are easy. When I say difficult, it is not that difficult. It is difficult because you may not like mathematics. But I'll try to make it simple as possible so that you won't feel the pressure. Let's begin. IP addressing. You see, the Internet Protocol, IP means Internet Protocol. This is actually a protocol. Only this protocol makes layer 3 happen. For every packet, layer 3 is important for identifying the destination to where the packet needs to be sent. Layer 3. In layer 3, we got a lot of information, in which one of the information is destination IP address. So the IP protocol is not only handling the address to identify device, it also does a lot of other things like fragment, TTL, quality of service. We call it as type of service, or we can also call it as DSCP bit. Lot of things the Internet Protocol does. TTL, time to leave, and much more. In which one of the things that IP protocol handles is addresses to identify device. We call this address as IP address because the protocol IP, the protocol Internet Protocol, uses this to identify a device. This Internet Protocol has got two versions as of now. Version 4 is 32-bit. Version 6 is 128-bit. Earlier I might have explained to you the size of MAC address. Did I? If so, what is the size of MAC address? Can anyone say? But MAC address is not layer 3.
Was it 64?
Sorry, yes. 64? No. Again, see, MAC address is not under IP address topic. MAC address comes under layer 2. Layer 3, only these two. 32-bit binary number and 128-bit binary number is IPv6. Now the size of MAC address, oh yeah, what did you say?
48.
Correct. MAC address is 48-bit size. IP address is 32-bit size. If it is IPv6, it is 128-bit size. Those beginning classes, like first three classes, I might have explained you these things. MAC address is 48-bit size. Anyway, MAC address is not our today's focus. Now, this 32-bit only, we have to serve the entire world. Just 32-bit binary number. We need to use it to provide identification for every device that wants to interact on this earth, which is a big challenge. Only 32-bit, and it is binary, so 2 to the power of 32. Whatever you get is the maximum that you can. Let's see, calculator. 2 raised to 32. So somewhere around 4 million plus addresses. But the number of devices in the world is many times bigger than what you saw now. Many times bigger than 4 million, many times. Colleges have got thousands of laptops and computers. Research centers have got thousands of laptops and computers. Hospitals have got many, many computers. In home also sometime we see around 5, 6, 7 computers. So everywhere computers. Ticket reservation, everyone uses computer. Computers everywhere. Cell phones, they also now act like a computer. They also go online, they need IP address. So every single device needs an address. With this 32-bit, till today, we managed to serve everyone. How is that possible? Just 4 million plus address fulfilling the need of the entire world. How is that possible? It is possible because of a few things. We are going to see one by one. In that, number one, classification. Now, this 32-bit address is classified into A, B, C, D, and E. A, B, C, D, and E. Truth is, there is no class E. But still, they will say, we are going to do something. So it's still under research and development. So far, nothing is decided. We already have version 6 now. This we are talking about version 4. Version 4, class E says it's still under research and development. In class D, we have range between 224 to 239. This range of address are called class D address. For example, 224.0.0.9 is a multicast address. The routing protocol, routing information protocol, RIP, uses. These addresses are not to be assigned to computers because these addresses are called as multicast address. They are designed to identify group. All those RIP running routers are identified with this one number, 224009. So multicast addresses are not for individual device. It is for group. To identify any group of device with single address, you need a multicast address. For example, Asians means every people in Asia is Asians. People in China is an Asian. People in Singapore is an Asian. That is how they are grouped. Those countries in that continent, Asia, are called as Asians. That's not for individual. That's for the group. Likewise, all those routers running the protocol RIP is identified with an address called 224009. There is another example I'll give you. 224.0.0.5. This is all routers that runs a protocol called OSPF. Open Shortest Path First. So we got some addresses which are meant to identify group, not individual. Those address that identifies the group are class D addresses only. Class D addresses. And then the class D addresses, how do you identify? They are in between this range 224 to 239. So the first octet, when you see, this will be a number between this and this, or it can be the same number also like this. It can be any number between this and this multicast range. Only the first octet you should see. Don't see this octet. See only the first octet. If the first octet number is any number between 224 to 239, then that is a multicast address that cannot be assigned to an individual device. Try doing it. You don't accept. Let me try doing it. If you try assigning, you can try on the real device or you can try on packet tracer. Let me try it on real device. Oh no. See, I'm just trying to assign an address starting with 224. See, immediately it says, this is not a valid entry. Please specify a valid number between 1 to 23. So 224 you cannot assign to a device because it is for identifying a group of device, not individual. So this operating system that I am running in my laptop is developed as per the standard. So any operating system, it may be Linux or Windows or anything, they will accept this number between 224. I tried 4. It just turned it to 3 actually. I did not type this 3. So I was actually typing 4. But it says 3 is the last number. So I cannot take here 4. All right. Now, one thing we understood here is we can also identify group of device with one single address, which is called as multicast address. Next is Class C. Class C ranges between, and for a long time I did not record, it was past. Anyway, I'll quickly brush over what we saw because the recording did not happen for some time. So I said multicast addresses, any address between these two range, means 224 to 239 is multicast address. For RIP routers to identify, we use this address. For OSPF routers, OSPF, we use this address. All the routers that runs OSPF as a routing protocol will be identified with this address or identified with this address. Class C address ranges between 192 to 223, example 192.168.101. Class B address is ranging between 128 to 191, and Class A is 1 to 126. So what I was talking is 127 is neither Class A nor Class B. It is because it is reserved as loopback address. What is loopback address? This address, if your PC can ping, then your PC is eligible to be a part of the internet. If that ping doesn't work, then you need to troubleshoot. CMD, command prompt. See, when I say 127, some number I'm going to type after this. 127 is important. The first number should be 127. The rest of the numbers can be anything like 56.67 or 76.100, any number. It doesn't matter. The first number, if it is 127, then it is called as loopback address. You see, I'm able to get reply. But you know very well, I randomly typed some number. There is no device with this address. There is no device. Say, for example, I'm going to put now 127.100.250.255. Okay, there is no 250. There is no 5 numbers. Only 4 numbers you should type. You see, I'm getting a reply again. Who is responding to me? Do we really have a computer or any device with this IP address? No, there is no device with this IP address. Then who is replying me? I'm getting a reply. Whenever I type something with 127 in the beginning, immediately someone is replying me with the same address which I am pinging. With the same address that I am pinging, someone is responding me. Who is that someone? It's your own device responding. It's your own operating system responding. This is what called as loopback address. You know, in OSI we have 7 layers. When I ping from the application layer, the packet goes down to the physical layer and comes back as a reply to the application layer. So when you are able to ping any number starting from 127, which means you have 7 layers of OSI in your laptop, is fine. So it's a kind of diagnostic tool. Ping 127 helps to diagnose the problem. If you're not going online, how you know the problem is with your laptop or with the with an internet service provider or with some destination. How do you know that? How do you know? How do you isolate the problem? First, you try pinging this in your laptop. When you are not able to ping this 127 number, 127 dot any number x dot x dot x. If you're not able to ping, I tell you the problem is not in the service provider side. It's in your laptop side. You need to fix your laptop. There's some issue with your laptop if you're not able to ping 127 dot some x number. Now go to your command prompt and try pinging an address starting with 127. Try and let me know now. I'm waiting. You will be able to ping because you're already going online. Go to command prompt, type CMD and go to command prompt. What happened? Have you tried?
Yes, sir. I've tried with the 127 IP address. Yeah, I was able to ping.
You get reply. So when you're getting reply, it means that OSI 7 layers are working fine. So if you don't get reply, what should we do? When we don't get reply, you need to check with the drivers, the network driver. If the driver is not properly installed, you will have the problem of not pinging. So the network card, the network card needs a driver. Sometimes the network card itself is in loose connection. It's not properly fixed into the slot. So two things you need to check. First, the physical thing, whether it is fully seated inside the slot. Secondly, the driver that needs to drive the card. Anyway, in the laptop, you won't have the problem of installing the network card because it's properly installed. It is compact. The laptops are tightly compacted, uh, compactly fitted in, so that won't be a problem. But in the desktops, there are chances sometime the the network adapter is not properly seated into the slot, maybe due to shipping or not properly installed physically. So we need to take care of that. Secondly, the driver needs to be installed. Say, for example, in my laptop, if I show you the driver, go to control panel. In the control panel, go to this device manager. In the device manager, you see list of peripherals in my laptop, and you see the network adapter. These are the drivers, and especially this one, 802.11n. This is my Wi-Fi driver. My Wi-Fi. I'm talking to you because this driver is here. Broadcom 802.11n network adapter. So this driver, if you right click and you see update driver, disable device, uninstall the device, update driver. So if your network is not working fine, means if your laptop is not properly functioning, you can check the driver. See, my driver date is 02/06/2013. Almost 10 years now. For 10 years, this driver was installed in my laptop. 10 years. It's working fine. But if you want to update the latest one, you can click on this button. I'm not doing that. Now, the drivers, if you properly install, problem solved. Fine. That's about the loopback address. Now, what is the connection between this and the one which we are talking earlier? Earlier, I said with this 32-bit, we are meeting the needs of every people who wants to go online. For that, there are a lot of things done. One of the things is classification of address. How it is related to supplying address to the entire world. Let's say you have an orphanage. In the orphanage, you got like 30 children. 30 children in an orphanage, you are running an orphanage, there are 30 children. You got only 5 cakes. Only 5 cake. You want to share it with 30 children. Only 5 cake. How will you do that? Now you will classify the children. Okay, I got 30 children. In the 30 children, how many children or of age between maybe age less than 10, less than 10 age out of 30? How many are less than 15? How many are 20 age? Less than, between 15 to 20. So you got 30 children of these ages, like in between. You got children from age from, let's say, 3 to 20. 3 to 20 years old children, 30 numbers you have. And what you do is you take this 5 cake. For this children, this children in between this age, you want to give a little bit bigger. For these children less than 10, you give very small piece. Small pieces you make and give them. And for these people, you give medium size. For these children, you give the big one. So that 5 cake, you cut in 3 different size for 30 children. 5 cake. You cut in 3 different size. Why? Because if I give the big size to kids, even though they like cake, they don't eat fully. They just, take to mouth and then they waste it. Children between 3 to 10 years old, they don't really eat fully because they cannot. They take like 2-3 bites and then they drop it. Even the children like cake. My children, every Sunday after church, we have to take them to buy ice cream from ice cream parlor. They like very much. But when I give them, they don't finish it fully. Just 2-3 mouths, that's all. Then the rest of the things me and my wife need to share and finish it. That is how children eat. So if we take the 5 cake, the big size one, and give to children of less than 10 years old, they're going to waste it. So what you can do is you can cut it into small pieces which they can eat without wasting, and keep the rest for the middle size and big size people. In that way, you can manage giving this 5 cake to 30 children. You know that if I give to small children, they're going to waste. So you give only small portion instead of giving the whole cake. Only small portion you give to small children. Rest, you have something left for the big children to give now. Yeah. So I may have 5 small children. If I would have given 5 cake, means one each, then there won't be any cake for this group of children. But because I have taken one cake and cut into small pieces for 5 children, I have 4 more cakes left. And they're also happy. The small children, they did not waste any cake. So this is how, according to the need of the people, the 32-bit address is divided. For example, class A, this 32-bit, 8 plus 8 plus 8 plus 8. This is how the 32-bit is divided. So this 8 plus 8 plus 8 plus 8, 32-bit. In that, class A are the group of people who are grown-ups, who need more. So for them, we need class A. For them who needs more, like I have 60,000 employees in my company, let's say. I have 60,000 employees in my company. Then for each employees, you need an IP address because they need computer to communicate, to do their work. You cannot give class B to them. You cannot give like, let's say 1 million. 1 million employees in my company. You cannot give class B to them. Class B will supply you only 65,000. Class A can supply only 255 IP. So class A is the one which has got more bits for host and only 8 bit for network. So when you want more IP address, like million, let's say for example I have 8 plus 8 plus 8, 24. Calculator. Just comparison calculator. 2 to the power of 24. So if you need these many IP address for your organization or close to this, then you should be given with one address that begins with 1 or any number in between 1 to 126. Any number between 1 to 126 can provide you these many IP address. Any number. Say for example, if they give me 5, 5.0.0.0 till 5.255.255.255. What is the 255? 255 is the maximum that you will get out of 8-bit. I'll explain you in detail later. Now, what I'm saying is between these, how many addresses are there, These many addresses. 167777216 addresses. All right, so for those who need these big number of IP address or close to this, you need class A. Yeah, You need class A. Next, for class B, only 16-bit, 8 plus 8-bit is given for network. Sorry, the host. And for network, another 16-bit. So 16-bit for network, 16-bit for host. More host compared to class C. In class C, only 8-bit is host. All the rest are network. So you see, if you want IP address less than 255, use 8-bit only, then you will have class C address. My company is very small. Let's say I have only 50 employees. Then I should not buy one class A, because if I buy class A, I'm going to waste a lot of address. I just got 50 employees and I need only class C. And if I have only 65,000 employees, then I need only class B. For example, you see, I wanted to calculate again. It is 2 to the power of 16. You see, 65,000. So if you have employees of this number, then you will need class B. And 2 to the power of 8 is only 255, only 256. So if you have employees less than this, then you need to go for class C. It means you will be provided with class C, because you won't waste. If I give an address from class A to this company whose employees are only 200 or 200 people, let's say, only 200 employees, but if I give this big size, class A is very big size, right? What is that? 2 to the power of 24. That's a big number. But the number of employees, number of IP address needed is only 200. Then you are going to waste big number of IP address. So when we take this 32-bit and properly plan like this, don't worry, you don't need to plan it. It's already planned. You need to simply take and give it properly and use it proper. Now, this is one of the step that manages to meet the entire world requirement with just 32-bit. Just 32-bit. Like you can manage giving cake for 30 children with 5 cake. When you can manage that 5 cake with this 30 children, just 5 cake only, but there are 30 children in your orphanage. If you can manage by cutting the pieces in proper size according to the capacity that they can eat, and make them happy, everyone is happy because they all got cake. All 30 children got cake. But the number of cake given to you was only 5. So when we properly utilize it, when we plan it and use it, you can still meet the need. This is how the entire world is now going online. 32-bit only. But the entire world is communicating. Classification helps to wisely divide and use this 32-bit. Now, class A ranging from 1 to 126, class B ranging from 128 to 191, class C is ranging from 192 to 223, class D is multicast range 224 to 239. Now I'm going to explain you how you got this range. How you got this range. But before that, I want to remind you something. For network, in class A, only the first octet is given. In class B, the first 2 octet is given. In class C, the first 3 octet is given for network. So, more the number of bits for the host, more IP address you get. Host is nothing but the device that communicates in the internet. They are all called as host. Host. So for each computer, means for each host, you need to provide an IP address. More host bits, that more IP address. Class A has got more IP address, 2 to the power of 24 IP address. Class B, 2 to the power of 16 host. Because I got 16 bit. Class C, 2 to the power of 8. And also you need to subtract -2 from all this. 2 to the power of 8 minus 2 is 224. How you got it? 2 to the power of 8 is 226 minus 2 is 224. Why we do minus 2? For example, class A address, let's take 200.1.1.0. This is class A network. See, first 3 numbers are network. This is network, this is network, this is network. And this is class C. How I know? Because it's 200, which is in between 192 to 223. Now, the first number 0 cannot be used. This is the very first number. You cannot use it because this is to identify network. This is not a valid number to be assigned to a computer. Likewise, 200.1.1.2, 255, we don't use. This is the maximum that you will get out of 8-bit. You cannot use this. You don't use this last number, you don't use this first number 0. The last number is called as broadcast address. The broadcast address and the 0 number, we don't use. The last number and the first number. The first number is 0, last number is 255. You don't use this both. That's why we put -2. Let me write one example in class A. In class A, 10.0.0.0. See, 10 is the network. These are the host bits, and this is 0. Do we use it? No. You cannot assign this as an IP address to any device. Likewise, 10.255.255.255, you cannot use because this is the broadcast address in the 10 network. That is why -2. You don't use 0, you don't use 255. Do you have any question in this so far?
No, sir.
Nope. I know I'll go back over it because of the math.
Okay, I understand.
I'll go back over it.
All right, we have classification. That's one way to save, to use IP address properly without wasting. Class A, Class B, Class C. Now, before I go to the next next step that they took to save IP address, use it properly. Before I go to the next one, I want to explain you how they got this range. How this class A is 1 to, let me write it down again. class A is 1 to 126. How, from where they got this range? Why it is 126? Why not 150, a round number? Or why not 100? We'll discuss that. And for class B, we saw it's 127 is Lubeck, so 128 to 191. What is this 191? Why not 200? And class C, it's 192 to 223. Why not 225? Why it is 223? We'll discuss. And for class D, 224 to 239. Why 239? Easy. You know what they did? To classify, what they did is, in the first octet, I said 32-bit is divided into 8-bit, 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 8-bit is 32. 4 times 8-bit is 32. Now, in the first 8-bit, in the first 8-bit, they did some reservation to derive this. Only in the first 8-bit. So in class A, the first 8-bit, 3, 4, 5, 6, 7, 8, in the 8-bit, they did some reservation. To achieve this range, some reservation is done. And this is it. You know what they did? They made this as constant. Oh no, I'm making a mistake. 10, this is right. This is 110. This is 111. 0. See, easy, simple 0, 10, 110, 1110. They made this numbers constant, meaning whatever I have written in red, you cannot change it. Means you cannot change this as 1. You cannot change this. See, binary means 1 or 0, right? That is called binary. But you cannot change this. It's made constant. That's the meaning. It is made constant, meaning you cannot change it. Now you see the blue numbers. This is not valid one. So which is valid one? This is valid one. This is the smallest one, right? That's why it begins with 1. The smallest. Now what is the biggest one? The biggest one is when you make all this blue 1. That's the biggest, the maximum that you can get. This is the maximum. Now what is the value of all this, you know? This is 1, this is 2, this is 4, this is 8. Just I'm doubling. 16, 32, 64. When you add all these things, you get 127. I told you 127 is loop back. That's why I written up to 126 here. Actually, 127 also belong to class A, but you don't call it as class A because it has been given. It is given to another purpose. It is given for loopback address. It is taken from class A, though it was in class A range. It is taken out from class A and given for a purpose called loopback address. I already explained you why do we need loopback address to diagonalize. Fine. So 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 127. That's how you got this range. Now next, look at this. Is this a valid one? Of course it is valid. Why? Because I got 1 here. I have written up to here, this is 64. What is this? If I double 64, what I'll get? 128. That is why it starts with 128, because you got 1 there. And this is the minimum. What is the maximum? Maximum is make all these ones. This is the maximum that you can get out of this range. Okay, you will get 191. How? 128 plus 32. You see here also written 16, 8, 4, 2, 1. Binary will always double. That's why you see 1, 2, 4, 8, 16, 64 and 128 doubles. Why this 64 is not added? Because it has got 0. You should not add that. Anything multiplied by 0 is 0. So starting with 128, ending in 191, you can count and see 128 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. You will get 191. This is how you got this range. Now, class C, you see, and all this are 0, but still it is valid because you got 128 plus 64, which is 192. And when you make all these 1, you get 16 plus 8 plus 4 plus 2 plus 1, which is 223. 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1 is 223. Now, next. How do you got class D? When you add 128 plus 64 plus 32, you get 24. And when you make all this 0 as 1, you get 220, so 239. 128 plus 64 plus 32 plus 8 plus 4 plus 2 plus 1. Here actually we got 16, but we don't consider it because it is 0. Likewise here we actually got 32, but we don't consider because it is 0. Here actually it is 64, we don't consider because it is 0. You see, this is how they got this range. Any question on how we got this range?
No, sir.
Even though it is not much important, at least once in a lifetime we should know this. At least once, there is a reason behind that we need to know. There's a logic behind. You should not think like, why it is 191? All-time doubt. You should not have that doubt. Why it is 191? Why they have done this? Why can't it end with 200? You should not think like, why always? So there should be some answer. This is the answer for this range. This is the answer for this range. Okay, well, it's not that important, but you should simply know this range. Class A means 1 to 126. Class B means this you need to know by heart. This you need to know without doing any of this calculation. But you also need to know very well that there is a reason behind this range. This is the reason. This is how they got this range. They've not blindly set some number and made it as a standard. There is a logic here, you see. I showed you. All right. So don't forget these numbers. That is important. B means 128 to 191. C means 192 to 223. Should know the range. Now, going back again. We saw class A. First octet is network. Means octet means 8-bit. I told you that 32-bit is divided into 4 group of 8-bit. 4 group of 8-bit, in which only the first 8-bit is network here. With 8-bit, what is the decimal value you get? If all the 8 bits are on, you get 255. And all the 8 bits are on, it's going to be 1, 2, 4, 8, 16 plus 32 plus 64 plus 120. When you add all this, you get 225. So to say that the entire 8-bit is given for network, we write subnet mask like this 255.0.0.0. What does that mean? It means that in class A, the first octet is already meant as a network bit, all the 8 bits. They cannot be used for identifying host. For the host identification, you got other 3 octets. You cannot use any of these bits from here for host identification because they are given. To say they are given, you say mask. It's been already covered, used for network. In class B, first 2 octet is network. So the subnet mask of class B is 255.255. What is this SM mean? Subnet mask. Subnet mask. Mask. Don't forget why class B 255.255.0.0 as a subnet mask, because in class B we saw on top we saw class B first 2 octets or network. So when you see 255.255, you understand, okay, the first 2 octets are network. Class C, first 3 octets are network, So the subnet mask will be what? 255.255.255.0. So by seeing 255 three times, I understand that out of 4 octet, 3 octet is network. Right, so subnet mask helps to understand how many bits in the IP address is identified as network and how many bits are identified as host. So when I see an address in class C, for example, 200.0.0.1, I understand this one is the host and these three are network because it is 255, 255, 255. 200 is in between 192 to 223, class C. So in this address, I have two portions. One is network portion, another one is host portion. How do I know that these three are network? Because the mask for class C means 255, 255. What is the other meaning of it? It means that it's 200.0.0th network. In that network, this is the first host. So when an address is given, how you know how many bits out of 32 is network and how many bits are host? By comparing the subnet mask. Class C subnet mask is 255, 255, 255. Then I understand that 200.0.0 is the network and .1 is the host. See, these are all fundamentals and very important to know. And you are learning this for the first time, so it may sound like too heavy for you. But if you'll spend 1 more hour, 1.5 or 2 more hours with this video that I give you after the class, it will become easy for you. Only then tomorrow's class will be interesting. So Bedru, please, I request you, once the video is provided to you,